Hello and welcome to another episode of Modular in a Week. And we stay one more episode on day 13. I talked in the last episode that I wanted to do a Bitcrusher, and after I said that and after I did the video, I went and looked at my parts bin and I found the ADC 0809. So an 8-bit analog to digital converter. You get one signal in and you get 8 bits out parallel. 8 bits out. And my idea is that I can use this and just an R2R filter afterwards to just do a simple DAC digital to analog converter and get the digital signal back to analog, and then just switches on these 8 outputs to turn the bits on and off. So that's the initial thought. And this video is now to see if that is possible. But before we sit down and look at this, I'd like to say thank you to my Patreons. You are amazing. Thank you so much for your support, which makes it possible for me to do all these videos and all the stuff that I do around here. So thank you very much for that. So let's sit down, look at some data sheets and some ideas on what we can do with this. Alright, so this project has gotten away from me a bit, so I thought this would be the best way to explain this. The thought I had in mind was to take the audio input, run that through an ADC, the 0809 that I have right now, get 8 outputs from that ADC, so 8 digital outputs. Those outputs, and this is really overkill, but just to get all the functionality, I want them to go into a breaking jack. So if nothing is connected to the jack, then the jack is then connected to a switch, which is then connected via the breaking connector of another jack, which then goes into an R2R network or a DAC. So this is a really simple DAC, just a bunch of resistors in a special configuration going down. And then this ends in a small amplifying circuit. Then I should low pass filter this to get the digital signal a bit smoothed out. That is optional, I guess. And then just to raise the output a bit again, because I need to attenuate the input so it doesn't distort in this. So you do this 8 times down there, and then you have a really fast clock going in, running this chip to chop up the sound. And so the clock is the one we did in the last episode, this one with the LTC 1799, which we went through, this one, and we did the circuit down here. If you haven't seen that, go back and look at that one if you want a clock for your projects. The ADC 0809 is just a chip that I got this kit, as I said. So I started by building this kit just to figure out how to connect it. And I will try to make schematics for this. It's quite simple. I just did it according to the manual. The only thing I had to add to get the constant switching of bits is to connect end of control to start to each other, so it just loops really fast with this cable in place. And then from there, this is how a R2R network looks like. You begin with the LSB, stands for least significant bit, so the 1. and then most significant bit, which is 128. So goes like that, and then into the op amp. An R2R network looks something like this when you have it on a breadboard, and this is what you saw a bit of in the last episode with when we did the clock with the sound examples there. And right now this is the final product of this. So as I said, I kept this board. I could have just soldered the IC on here, but I have a few more things I want to try out before I feel this project is finished. But so you see the input signal comes here and is attenuated down and into one of the inputs, and then we have the super fast clock here with all the switches and pots still there, so we can do sample rate reduction. So there's a lot of things that can be done here. Sample rate reduction is done with this pot and this switch. And then we go into the R2R network, or no, we go into the switches before the R2R network. So here we can take any of these bits going out here. And the reason I wanted to have these is because there's something else called bit swapping. So I can change, so the least significant bit on the output is the most significant bit by just adding a patch cable between these two, which opens up for some really fun creation of waveforms, I guess. So instead of we can look at that in a bit. So that's what all the jacks are for. And then the switches are for just turning the bits on and off. So starting with the least significant bit, we can start to crush the bits by turning them off like so, down the line here, and while we're there, we've crushed 4 bits, and we now only use 4 bits left, which really slows or lowers the resolution in the amplitude, so to say. And then another 8 of those. And then here you have the R2R network here, a bit more compressed than this, but of course it's easier with protoboard, into an op amp. And as I said, I need, we'll check this out, and then we'll add the low pass filter afterwards and amplify the signal a bit more. So that's the 2 things that are left here. So yeah, to make a long story short, this is the end result. So let's just take this and listen what you can do with this. Alright, so here we have it plugged into the Modular, and I'm routing white noise through it now. So here is the original signal. And what we got out right now is and let's start with the sample rate reduction. This is really slow. We move up times 10. And times 100. So this is what we got. If you compare again to the original signal, it is a bit more low pass. I'd say. Let's go over to the bit crushing. So yeah, let's just turn off the bits here. So we turn off the least significant bits. See, the waveform is starting to not that many levels anymore. And there, at 3 bits, it turned off. So if we, let's see. So here we see that there's basically 2 levels. We turn this up, and we now have 3 levels. And this would be 5 levels then. And then it just goes up from here. And it gets more and more complex as we turn the bits on. And this is all bits on. At a really 20 microseconds, that's what we got here. So then we can also turn just the least significant or most significant bits off. And now we get more of the, so this is a high pass. Let's instead take a sinus wave, and as you can see, this is not a sinus wave, it's a bit too round at the top, and that's because we're overdriving the signal. There we are below the threshold of what this can handle on the input. There is, so I need to address this as well, because I don't have the lower part of the waveform, which I think is because of that I need to put the reference voltage somewhere in the middle, which I haven't done, and I haven't tried that yet. So, but this is what we got right now, somewhat of a sinus wave. There we have it. And if we do some sample rate reduction, you see that in this way the sample slices gets larger until we basically have a square waveform. And here we see it's starting to become something of a sinus wave. Even more here, until we finally are up here where you can, it's still jagged, and that's where the low pass filter comes in, but it is a sinus wave. What happens if we switch bits here? So you see it becomes jagged, more jagged, but this time in this axis. So 4 bits, taking away 5 bits, and we got a square wave, and 6 bits was too much. We can again do it from the bottom with the most significant bits. Here's some really interesting things what happens to the waveform. Folding or something happens. So just the least significant bit works quite well actually. And we can just turn off one bit in the middle. We get the small Batman hat. Whatever that is. It's a castle. So just turning the bits like that can make for quite some fun waveforms. So what happens if we take the least significant bit and swap that with the most significant bit? There, and connect that there. Didn't do too much difference, but we can see that we're almost turning it around. We're building on top of the waveform instead of below, which we don't. But we're following the big waveform, but with spikes up instead. So we can get some really strange waveforms doing bit swapping as well. So I have a few things. I want to try the low pass filter, I want to try another clock, and the output amplification to get to the same level as the input. So those are the three things I want to still try out on this. And I need a panel. This does not work to work with. Another cool module. I really like this module, and it's, as I said before, this has been on my to-do list for a long time. It worked over my expectations, even though I still have a few kinks to work out. I didn't have time for that if I was going to get this video done in time. It did take a long time to conceptualize, get into a working thing. Yeah, one of these ADC kits for a few dollars, a whole bunch of resistors, jacks and switches, which of course you don't need everything of this. You can skip the bit swapping maybe and just do the bit crushing, and or only do the sample rate reduction, which I think is a really cool feature and effect that you can do with this. Yeah, I really need to put this into a module though, because it's really difficult to work with. Hope you like this. Next week will definitely be, or next episode will definitely be the last day, first episode of the last day of this never-ending week. So yeah, hope to see you then. I'm gonna try another clock for this one as well, so that's gonna be next week's video will be about this one again with another clock. I hope that will work. And then day 14. Have a great week everyone, and take care. I'll see you next time. Bye.